Good morning, everyone. Older back here with another video. Today we're talking about two vocabulary words, coterminal angles, so that right there, and reference angles. And this should, after watching this, you should be good for the rest of concept 34 in Delta Math. So we're going to go through a couple examples of each one. So let's get started. So the first one is coterminal, and so it says find a angle, and the way you pronounce this symbol right here is theta. That's a Greek symbol, theta. We usually use that to represent an angle. So when you see that, generally it's an angle. So find an angle theta coterminal to 1,147 degrees. And then what this piece over here means, you would say, what this is saying is theta, our angle, should be between 0 and 360 degrees. So that's important. So it can be equal to 0 or it has to be less than 360 degrees. Can't be equal to 360. So basically what coterminal angles are talking about is every time you go around the circle, right, that's 360 degrees. So if I go around once, that's 360. If I go around twice, that's 720. Go around a third time, that's what, 1080, okay? And basically every time you go around, you start over again. And so a 360 degree angle is the exact same thing as a 720 degree angle, which is the same thing as a 1080 degree angle. So when we talk about a coterminal angle, it's basically saying, all right, we have this really big angle. What is its small angle? Its angle that's less than 360. So we don't have to go around and around and around to find where it is on the circle. So where basically is the angle 1,147. So it's pretty straightforward. You just start with that number, and every time you go around the circle, that's 360 degrees. So you just subtract off 360 degrees. So if you subtract off 360 from 1,147, you get 787 degrees, right? Still, that angle is still not less than 360, so you subtract another 360 off, or you go around the circle a second time. And if you do that, you get down to 427 degrees, all right? So again, still bigger than 360, so we go around a third time and subtract 360 more, and you get 67 degrees, right? And so that right there would be your answer. That's what you're going to type into Delta Math. That's the angle, that's theta, that's between 0 and 360, right? And what we would say is that 67 and 1,147 are coterminal angles, because they would, if we were to drag this dot around 1,147 degrees, it would be at the exact same spot as 67. So technically 67, 427, 787, and 1,147, those are all coterminal angles. All of those would land at the same spot on the circle. All right, but what we're looking for is the angle, the smallest one, that's between 0 and 360. Okay, so there's the first one. Let's do another example. So here we go. We got 1206. All right, again, we would have to go around the circle multiple times before we got to where we'd land. So again, you just start subtracting 360. So one time around the circle is 360. That would give you 846. Still need to go around again, subtract another 360. It's another time around the circle. That gets you to 486. Right? Go around a third time, so subtract another 360, and you'd be left with 126 degrees. And that would be your angle theta that's in between 0 and 360, so that would be your answer. And so again, the angle 1,206 is a coterminal angle with 126. Technically, it's also a coterminal angle with 486 and 846, all right? Because they would all be at the exact same spot on the circle. All right, so basically all you do is you subtract 360 from the large angle until you get down to an angle that's between 0 and 360, and that's your angle. That's your coterminal angle. Okay, hopefully that makes sense. So the second word is this thing called a reference angle. And this will come into play when we start talking more specifically about a unit circle that is and we're trying to find the coordinates of the unit circle and things like that. You'll use a reference angle to do this. And basically a reference angle is an angle, so if it's angle theta, its angle will be between 0 and 90 degrees, okay? That's what the reference angle will be. So your final answer should always be smaller than that. So again, we're dealing with an angle that's bigger than 90 degrees, all right? And so we got an angle that's 240. So step one, and for this particular one, though, the assignment that says guided is they give you an angle, in this case it's 240, and the first step is to take this yellow dot and drag it to a 240 degree angle, and you'll just easily do that. And so after you do that, you'll get that right there. That's what will appear. So that angle right there is 240 degrees, right? And the reference angle is the angle, the 90 degree angle, or the angle that's less than 90 degrees, that's created with the x-axis. That right there. So if you create this right triangle right here with the origin, or basically the radius of the circle is the hypotenuse of this right triangle, that angle that's created with the x-axis, and it's always the x-axis, is what we call the reference angle. So how do you find it? Well, you got to do a little bit of math. So this angle right here is 240 degrees all the way around. And we know that this angle halfway around is 180 degrees. So what's the difference between 180 and 240 right there? Well, you just, do a little subtraction. You get 60 degrees. And so that angle right there is 60 degrees. Right? And that's your answer. And that's what you would type in right here would be 60 degrees. All right. Again, this will come into play later on, but that's how you find a reference angle. It's an angle that's created by making a right triangle, and the angle that is the reference angle is the angle that is the angle created by the x-axis and the hypotenuse, all right, of that right triangle. Is how you find it. Let's look at another example. So this angle is 147 degrees. So if you draw that in the circle, you get that. So that angle right there is 147 degrees. Okay. The reference angle is this angle right here. It's the angle in that right triangle that you draw. That is the one with the x-axis and the hypotenuse is the reference angle. So how do we find this one? Well, it's a little bit different, right? So again, all the way around, so if we went all the way around, that's 180 degrees. And we want to find this angle, so it's the difference between that 180 and that 147. So here we would do 180 minus that 147. And if you do that, you get 33. So that means that that angle, so 33 degrees, is that angle right there. That's that reference angle. So it's different every time. So sometimes you subtract the angle from 180. Sometimes you take the angle and you subtract 180 from it. Sometimes we'll use 360, which we'll see on the next example. But it's always, if you create a right triangle with that angle, and it's the angle that is created from the x-axis to the hypotenuse. Okay, so the answer to this would be 33. We type that in around there. All right, let's look at one more of these. So again, 305, you draw the angle, you get something like that. The reference angle is this angle right here, again with the x-axis and the hypotenuse. Remember that 305 is all the way to there. That's 305 degrees. All right, so the reference, how we figure that angle out is, well, we think about if we went all the way around, that's 360. And if we went all the way to our angle, that's 305. So the difference between those. So in this case, you would subtract 306 and 305. You'd find that difference. All right, and so you'd end up with, in this case, I believe, was that 55? 55. Here. And again, your final answer should always be between 0 and 90 degrees. All right, that's what theta should be. So you should always know that you did it correctly. Okay, and the second thing again is when you make your right triangle, it's always the angle you're finding is between the x-axis and the hypotenuse. Okay. All right, so that's the one where it's guided and it draws the circle for you. On the next example, all they're going to do is give you an angle. And so in this case, they just tell you it's 255 degrees. I drew this circle, and I would recommend you do that when you try these, but they won't give you that. All they're going to give you is this line right here, and you need to find the reference angle. So we would first estimate where 255 degrees is on our circle. So remember 90, 180, 270. So it's somewhere in here. All right, 255 we estimate, right? So we do our 30-degree increments. And you don't have to be perfect on this. This is just trying to get close. So there's 240. So 255, I'm going to estimate is right about there. So that angle, if I draw it, that angle right there is roughly 255 degrees. So what I'm going to do now is create a right triangle. All right, and again, I'm going to always use the x-axis to create this right triangle because that's how I find my reference angle. So if I draw that right triangle, all right, there's my right triangle. The angle I'm trying to find is that one right there. All right, and so how do I figure that out? Well, it's the angle from the x-axis back to the hypotenuse. So 255 is all the way to my angle, and 180 degrees is to right there. So it's the difference between those two. So I'm going to subtract those two. And if you do that, you get, I believe that's 75 degrees, and that would be your answer. Okay, so all again here I'm doing is drawing the circle this time. They don't give it to me. And I would, again, recommend that you do it. Okay, you can try to remember when to subtract 180 and all that. Again, you'll forget. So just draw the circle to be sure. Let's look at another example. All right, 166 degrees. So again, let's figure out where that is. 180 is right there. 90 is right there. It's somewhere in between. Break that into 30-degree increments. 120, 150. So 166 is going to be like, somewhere in between there, maybe right around there. So again, we don't need to be perfect. Somewhere right there. So that angle right there is 166 degrees roughly. So I'm going to make my right triangle, and again, I always use the x-axis, right? And the radius is the hypotenuse. So that right there is my right triangle. And the reference angle is the angle that's created with the x-axis and the hypotenuse, which is that angle right there. So we know halfway around the circle to right here is 180. So it's the difference between 180 and 166. And so I'm going to find that difference. So that's 14 degrees. And that would be my reference angle. So it's got a reference angle of 14 degrees. All right, one more. 348. Again, here's 270. Here's 360. 348 is going to be pretty close to 360, so maybe right around there. Not perfect, but let's say it's there. Doesn't have to be perfect. So that angle all the way around is 348. 348. Okay. So again, I'll make my right triangle using the x-axis and the hypotenuse, or the radius as my hypotenuse. That right there is my right angle. My reference angle is the angle created with the x-axis and the hypotenuse. So that angle right there that I'm drawing on. So again, all the way around. So we went all the way around to there. That's 360. 348 is all the way to there. We need to find this difference between those two. So we subtract 348 from 360, and you get 12 degrees, and that would be your reference angle. Okay, so there you go. 12 degrees is the reference angle. Again, your final answer for all of these reference angles should be between 0 and 90 degrees. All right, the final assignment is one where he puts all three things together. So you also want to try that one. All right, and again, if you don't know how to do this still, send me an email. Do my best to answer any questions you have. Thank you.